Now, continuous sterilization. It offers more flexibility in the choice of time temperature condition. Advantages of continuous sterilization over batch sterilization. It is superior maintenance of medium quality, easy to scale up, easier automatic control, the reduction of surge capacity for steam, the reduction of sterilization medium cycle time, the reduction of fermenter corrosion. The continuous sterilization device, it includes three basic units. First is a heating unit. Medium is heated to the required temperature in the shortest possible time interval. The holding vessel. Heating medium is kept at a constant temperature for certain period. Cooling. Medium is cooled to the culture temperature. So this is the wall process. Here our raw material is gone past to the cooler, and then heat exchanger is there for a steam sterilization. So here the small heat is given, and after that the pipe is gone to the holder, and here the 3 to 5 minute is holding is occur. After it's sterile, it is go again to the its cooler and heat exchanger to give a cool medium, and it is a sterile medium. Working principle of continuous sterilization. The temperature of the medium is increased in a continuous heat exchanger, then maintained in an insulated serpentine holding coil for holding period. The hot medium is then cooled to the fermentation temperature using two sequential heat exchanger. First, using the incoming medium as a cooling source, and second, using cooling water. The type of continuous sterilizers. There are two types, direct and direct heat exchangers. Indirect heat exchanger. Indirect heat exchanger and cooling is carried out using some kind of heat exchanger like spiral heat exchanger and plate heat exchanger. Now, the spiral heat exchanger. Spiral heat exchanger are based on simple construction. It consists of two sheets and high-grade stainless steel. Stainless steel sheets curve around the central axis to form a double spiral. To achieve sterilization temperature, steam is passed through the one spiral and medium through the other inoculum current. Now, this is a spiral one. So how? Here the steam is added, the medium is added, and the medium is removed like this. The larger medium can be added. Now, plate heat exchanger. One is composed of multiple thin. Now, I gone through here. So here it is a plate heat exchanger. Here the cool water in, here the hot water in. So two type of done in the single heat exchanger, but here the contamination may be occur. This is the another figure I put it. Direct heat exchanger. The medium in the sterilizer is heated to required temperature by steam directly via an injector. There are two type of direct heat exchanger. Continuous sterilization by steam injection by flash cooling. Modified continuous injector flash cooler sterilization. Continuous sterilization by steam injection flash cooling. In this system, steam is directly injected into medium. Required temperature is less than 140 Celsius, is reached in a microsecond, so it is very good. Cooling is carried out in the flash cooler in the vacuum chamber like this. Here the steam is added, the raw material is added, the holder is there, the steam bead is there in the flash cooler, so it required a very less time to sterile a medium. Now this is a modified injector flash cooler. Here our raw medium is added in the preheat exchanger, the steam is added, the holding is there, the chamber is there, expansion chamber, and here after heat exchanger it also go for the cooling heat exchanger. So two type of exchanger is required, cooling and a preheating heat exchanger. In this system, the injection system is combined with the flash cooling. Advantages of direct continuous sterilizer. Very short heating time, may be used for medium containing suspended solids, low capital cost, easy cleaning and maintenance, high steam utilization efficiency. Disadvantage of direct continuous sterilizer. Foaming may be occur and condensation is also a big problem. So kinetics of continuous sterilization. The del factor has to be increased with an increase in scale. Increased del factor may be achieved while maintaining the nutrient quality constant. So Q is equal to ln x0 upon xt is equal to, is first equation, x0 is equal to concentration of essential heat labile nutrient in original medium, and xt is after the sterilization period. The destruction of nutrient may be considered as first order reaction, and if we take a natural logarithm, it gives up to ln x0 upon xt is equal to kt. Therefore q is equal to kt. The relationship between K and absolute temperature is described by Arrhenius equation. K is equal to AE upon E upon RT. Therefore, substituting value of K into equation 3 give Q is equal to ATE raised to minus E upon RT. Now, if we put A aside, Q upon A is equal to T E upon E raised to RT. And on taking natural logarithm, log Q upon A and log T minus E upon RT. So log E is equal to 1. Therefore, we are not considering. So ln T is equal to ln QA. So we put it T aside. Ln T is equal to ln QA Q upon A plus E upon RT. Thus a plot of ln